Hi, my name is James. I am a co-founder at Gimbal Labs, and this is a Cardano starter kit. It's been a while since I made one of these. Probably I should have checked. Probably March or April was the last time we released a starter kit. But we've been really busy building here at Gimbal Labs, both working on some internal projects and also helping other projects to launch. It's been really exciting. And as we prepare to release some things, to put some things in your hands, we're going to make a bunch of videos over the next few weeks, including bringing some starter kits back to life so we can kind of show and explain and teach you as much as possible about what's going on. Now, we're at a really exciting moment in time. Last week, the Alonzo hard fork took place on the Cardano testnet. And in a few days, this weekend on September 12th, it will take place on the Cardano mainnet. This is a huge achievement. And as you've hopefully seen, it represents just the beginning of really starting to be able to seriously build with smart contract functionality on top of the Cardano protocol. In this kind of exciting moment, it hasn't all gone smoothly, as you might have heard. And so I've had this idea for making this starter kit, and it feels incredibly relevant today, just to put this out in front of you. So just in case you haven't seen it, you know, there's been a little bit of controversy, or you can call it what you want to, about some issues and challenges with the Cardano UTXO model, unspent transaction output model. Okay. And maybe you saw Charles speak over the weekend. I definitely recommend taking a look at this video. Here at Gimbal Labs, we will be discussing the current status of the network and a lot of what Charles shares in this video at tomorrow's playground session. That's on Tuesday, September 7th at 4 p.m. UTC. You can join us in the Gimbal Labs Discord. And if you're watching this video much later than September 6th or 7th, that's totally fine. Everything you're going to see here is still relevant. And we do invite you to our playground meetings every Tuesday, again, at that same time, 4 p.m. UTC. All right. And finally, the Sunday Swap team, who was kind of at the center of launching this chatter across the blockchain industry about the status of Cardano, wrote one of the best blog posts I've seen in the last few months. It's a really good description of the challenge and of their approach to solving it, which they leave you with a cliffhanger at the end. But this is a really, really good place to start if you're trying to understand this problem. Charles also lays out some of the details here, and this Twitter thread does a really good job outlining some of the challenge as well, providing some other links too. This starter kit is for people who really haven't fully wrapped their minds around the UTXO model yet. If you're already a Cardano developer, if you've already played with the command line and have a good feeling for how the UTXO model works on Cardano, you probably don't need to watch this video. My intended audience is anybody who's still trying to build their own understanding of what a UTXO is. Maybe you've seen Lars talk about the model at the beginning of the Plutus Pioneers. And even if you're not a Plutus Pioneer, I do recommend looking up those videos as well. In the very first lecture, Lars gives a nice overview of what the UTXO model is and how it works. And other people have done really good work in showing this across the Cardano ecosystem and even in the Bitcoin ecosystem. My goal is not to rehash all of that I'm going to send you on your own research if you need to see other diagrams. My goal is just to show you on the command line what it looks like to build a transaction using UTXOs. I've done this in kind of a small workshop setting for small groups of people over the last few months. And especially when I'm talking to people who are not developers, this is really eye-opening just to see this insight, okay? So even though we're going to be working on the command line, I hope you'll stick around and just take a look. My goal is not to teach you everything about the command line or even how to run your own Cardano node. My goal is to play a little bit of show and tell right here. Just show you what it is so you have a better mental model for what the UTXO model is and how it actually works under the hood. Okay? So I hope I didn't lose you already. I hope you're still sticking around. Okay? Let's take a quick look here. Now, once again, I want to reiterate this. You do not need to be a command line expert to follow along with this video. My goal is to show you a couple things and for you to have a few aha moments in how all of this stuff works. And let's see how we do, okay? Please, please, as always with starter kits, if I leave you with burning questions, I hope you'll track me down. Ask them in the YouTube comments or on the Gimbal Labs Discord server. So what I have here is just an empty directory. What I do is I just keep Cardano transactions in a folder. So I have a new directory for the one that we're going to build today. Now the documentation for what I'm going to show you already exists. Okay. I'm basically going to be working through this documentation here that's on the official Cardano developers site. Except I'm not even going to show you the metadata part, okay? All we're going to do is build kind of the simplest transaction we can. And I'm going to follow precisely the steps that are outlined here, all right? So you could just skip watching this video and read this, but what I've realized is that sometimes people really like to see this as well, to see it in action, to kind of slow down and kind of have a chance to think about it along with the video. So that's what I'm trying to provide here, okay? There's another version of exactly what I'm doing here that features native tokens. So again, even if you don't have your own Cardano node running, even if you don't have Cardano CLI installed, you can follow along with this video, and then afterwards you can read through this documentation and see how much sense it makes. And even if your goal is not to be a developer, maybe this will help you wrap your mind around the structural design or how you might create solutions on Cardano. All right, I'm going to use this Cardano Scan Blockchain Explorer in just a moment. But let's dive into this. Okay, so I have an empty folder here. I also already set up some variables, okay? So I don't want you to worry about this if it's overwhelming. Basically, this is how variables work if you're writing in Bash on the command line. Okay, so I have a variable called sender. $signs just indicate that it is a variable, and echo just means say it back. Okay, so I have a sender and a receiver address just ready to go so we can play with them. This is a mainnet address. So I'm going to copy it here, and then I'm going to paste it into the Blockchain Explorer. And that's where I'll see that this address has a balance of a little less than 25 ADA associated with it. It's made a bunch of transactions, okay? And if I grab that other address, this is the receiver address, copy it, paste it here. This one has 5 ADA associated with it. And this is similar to what you would see if you opened up a Yoroi or a Daedalus wallet, okay? You would see your overall balance. You'd maybe see how many transactions there were, and you'd be able to send funds between wallets. But this isn't telling the whole story, okay? So the next thing I want to show you is a little more deeply what's going on under the hood here. Watch this. So Cardano-CLI, let me rewind for just a moment too. I'm already running Cardano node here, okay? This has to be running in the background. When you run a Daedalus wallet on a computer, this is running in the background, okay? You have a whole copy of the blockchain. So I have that happening on this device. And because I have it running on this device, I could do something like Cardano-CLI query the tip of the mainnet, and this would show me the status of my node, right? Like I said, it's September 6th. We are in, I think, the 4th day of Epic 288, right? There's been this many blocks minted on mainnet. We're in the Mary era. It's going to shift to Alonzo next week, okay? And because I have that running and it's all synced up, right? Whatever information Cardano-CLI returns to me will be keeping up with the mainnet, will be up to date, okay? And every time a new block is minted, my screen is updating here and tracking those, okay? You can see, looks like, right? 4 blocks per minute or so, not always, okay? All right, so next, let's see, Cardano-CLI is a powerful tool. You can do a lot with it, actually, but as you'll see right here, you probably wouldn't want to do most things this way, right? It's a very low-level tool that doesn't abstract away a lot of what's going on under the hood. And that's exactly why I'm using it today. I want you to see what's going on under the hood, okay? We're not going to use all of the commands you just saw there in that list, but we are going to use a few of them. So the first thing I want to do is query again. I queried the tip a minute ago, right? This time I actually want to query the UTXOs associated with a certain address, right? And one cool thing about a well-built piece of command line software is that it can have really good documentation. Actually, you're probably not going to be able to see all that. Hold on one sec. Do that one more time, okay? So if you go to query UTXO, then it shows me what else I have to type in order to use this command. I need to tell it which network we're connecting to, mainnet or testnet. And then there's a few different ways to filter these UTXOs. But what I want to do is I want to see all the UTXOs on mainnet associated with a certain address. And let's do the receiver one first. Remember, receiver is just a variable. I showed you that address a few minutes ago. And we looked at this address on Cardano scan, and it had 5 ADA. When I query the UTXOs for this address, I actually see that there are 2 of them. And they're represented in Lovelace. Remember that there's 1 million Lovelace in 1 ADA. So this address actually has 2 UTXOs, one of them with 2 million Lovelace, or 2 ADA, and another one with 3 million Lovelace, or 3 ADA. And of course, 2 plus 3 is 5, and that's why we see 5 ADA when we search for this address on a blockchain explorer. But under the hood, these are split up into 2 distinct UTXOs. Let's do the same thing for the sender address as well. This one, remember, had about almost 25 at 24.8 ADA associated with it. And check it out. It's actually spread out over 7 different transactions, 7 different UTXOs. What this means is that if I ever want to send ADA at the lowest level, I have to find sufficient UTXOs. So if I wanted to send 4 ADA, I would have to either consume this UTXO, which has 5 ADA in it, or this one that has 7 ADA in it. Look, this one also has some native tokens attached. We're not going to cover those today, but I am going to cover those in an upcoming starter kit. Or if I didn't want to break apart one of these UTXOs, I could grab a subset of these ones, right? I could pair up a couple of UTXOs that had sufficient Lovelace, right? Sufficient value in them to cover the 4 ADA that I wanted to send. So let's do that. Let's try to send 4 ADA from this wallet, from this, that's why I called it the sender, right? Because I'm going to send it from here to this other wallet right here. Everything I'm going to show you is happening under the hood every time you send value from one Cardano wallet to another. And thank goodness all of this is abstracted away, because you wouldn't want to do everything I'm about to show you every time that you wanted to send value. However, once again, the reason I'm showing this to you here is so that you can have a better idea of what's going on under the hood, and this can help you build, or at least imagine, what might be built on Cardano. And at the end of this video, maybe you'll even have a better idea for why it's challenging, right? Why have these challenges around parallelism and concurrency emerged over the last few days? Okay, let's play around with this. So, first of all, like I said, I got an empty directory right here, and I'm going to be working inside of it, okay? I already set some variables. I have a sender address and a receiver address set. And just to reiterate this one more time, this is just a variable, and I had to set this variable in order for it to work. Okay, so when I type $, and then sender in all caps, this is what my command line is going to read. Okay, I actually have one more variable called... Oh, I didn't set this up yet. Hold on. I'll be right back because I have to go do this. All right, I'm back. What I had to do there is I had to set up one more variable called sender key. And I'm not going to show this to you. This is the file path to a private key for that wallet that has about 24.8 ADA in it. All right. And it's just best practice not to expose this, right? I shouldn't even be recording this video and have those private keys on a networked computer. But I figure that risking, about 30 ADA is a safe investment because I want to show this to you. But if you're talking about significant amounts of ADA, if you're a stake pool operator, for example, you wouldn't store the private keys on a networked device. That's beyond the scope of this video, but there's other great videos out there. Charles even made one about security a few months back, so you can go take a look at that. But just to maintain some degree of security, I'm not going to show you the file path to those private keys, just to kind of try to set that example. Okay. All right. So I now have that variable, the signing key for this transaction, which we're going to use later. Like I showed you already, we have a sender address and we have a receiver address, and we need one more thing. We now need to store the transaction hash for the UTXOs that we want to use as we build up this transaction. So one more time, let's go to cardano-cli and query the UTXOs on mainnet at the address of the sender. All right. And I'm going to build 2 transactions today. I'm going to try to send 4 ADA with each one. And one of them, I'm just going to use a single input right here, right? Because 5 ADA is enough to send 4 ADA, right? And then I'm going to build another one from this set of smaller transactions, okay? So let's see. First of all, let's set a few more variables. So I'm going to call this one txin1. And the first txin I'm going to use is this one. And when I talk about this UTXO, I need to identify it by both its hash and its TX index, this, which is a 0 in this case, okay? 0. Okay, so that's txin1. Then for the next transaction I'm going to build, I'm actually going to input 2 UTXOs. Let's call them A and B. The first one, let's just use this one here, 3.19 eta. Okay. And that one actually has an index of 1, so that's what goes there. Again, you can follow along with the written documentation that I showed you at the start of this video and see if that makes sense. See if you can recognize a lot of what I'm doing in those written docs. And the second one, let's use this one, the 3 eta. That's more than I need, right? And that's also at index 1. Okay, good. So now I've got these input transactions ready to go. I've got the sender and the receiver addresses. I have a private key stored, the path to a private key stored as a variable. And so now I'm ready to build some transactions. Let's do it. When you first build a transaction, you need to draft an empty one first so that you can then calculate fees. So that's the first thing I'm going to show you. And I'm probably repeating myself here, but remember, all of this is going on under the hood in a wallet. And thank goodness it is, right? You want to talk about barriers to adoption. What if you had to do this every time you wanted to send value? Well, that's what the early days of Bitcoin were like, right? Until there were user-facing wallets and mnemonics that people could use to represent private keys, and the list goes on, okay? But I'm taking you under the hood here so that you can understand a little bit more about the architecture of Cardano and hopefully have some better ideas for how to build on it. All right, we're going to build a raw transaction. The first one is just going to have one input. We just called it txin1. But even though there's only one input, this one is actually going to have 2 outputs. Okay. We're going to have an output that goes to the receiver. We don't have to say an amount yet, right? So basically we have the address and then a plus sign and then the amount of Lovelace we're sending there. Okay. You can see those documentation I showed you earlier to see what this looks like when you want to send native assets as well. But I'm not going to try to cover that in this video. We'll do that real soon though. Okay. Okay, but we also do need to send the change back to the sender. We're not going to send everything, so we have to say there's actually 2 outputs here, right? And the rest goes back to the sender. So far, so good. All right. Then what else do we need? We got 1 input, 2 outputs. We're going to talk in just a minute a little bit more about this invalid hereafter, but I'm going to ignore that for just a moment. There's going to be a fee, but we haven't figured out what it is yet, so we're going to leave that as a 0 as well. And then we're just going to create an empty, we'll call this tx1 because I'm making 2 different transactions, an empty out file. Okay, and if this goes well, which it did, it looks like nothing happened, but if I do ls again, now I can see there's this file here. Okay. All right. And what else do we need? We need to now make another transaction. And let's do that. I'm just going to type it all again. I hope you're having a nice, I should probably have some background music or something. But hopefully this gives you some meditative time to kind of think about what's going on here and incorporate this knowledge into your own. Okay, so TX in 2, this second transaction we're going to build has 2 transaction inputs. And we just named those by variables again. We stored the hashes and the indexes up here. Okay, so 2 inputs. Once again, we're going to have 2 outputs. And for now, it's going to look the same. We're not attaching any values to this yet. We're just building an empty draft. Oops. Okay. And we'll call this one TX2.draft. All right, and there they are, both of our files. And we could look at either of these in a text editor, but we're not going to see much. We see this CBOR hex, an empty description. It's a transaction built for the Mary era. That's the era we're in. And actually, if you typed cardano-cli transaction view, and we look at this TX body file, TX1 draft, you see a lot more information here. Okay, but I'm not going to go too deep into this. I'm not going to show you this again. Okay, but just so you know, right, that CBOR hex actually encodes all sorts of information, kind of boring information right now because we didn't give it any values yet. All right, but that command does exist. Okay, so we've drafted these. Now we want to calculate how much it's going to cost to send each of these transactions. And each one is going to have a slightly different cost. This is one of the big points I want you to get out of this today. Okay, so cardano-cli transaction, once again, we're going to calculate the minimum fee. For what? Well, for those transactions we drafted. Okay. This one, the first one, had 1 input, just those 5 million lovelies. And it's going to have 2 outputs. The sender gets the sent amount, or sorry, the receiver gets the sent amount, and the sender gets the change. Okay. There's also, we have to tell it how many witnesses there are. These are signatures. We only need 1 witness here because there's only 1 address from which we are sending UTXOs. So that private key needs to be used to sign this transaction. And that's what we're going to do, right? We are currently building. After we build a transaction, we sign it. This can actually happen offline. More on that in a minute. Okay. And then finally, we submit that signed transaction. But if you ever heard of multi-signature or multi-sig, this is what we're talking about. You can have multiple witnesses. Suppose that you're building a transaction where some of the inputs come from this address and others come from that one. Well, you're going to need the signature for each of them. Even better than that is part of Plutus is not just having wallet addresses, but having contract addresses, right? These are automated scripts that can look at an oracle, for example, figure out if something is true, and then if it is, sign the transaction, okay? If you want to learn more about that, go check out Plutus Pioneers, okay? That's beyond the scope of this lecture, but I just want you to have this idea about witnesses and signatures in your mind as well. Okay, we're submitting this to mainnet, and we're using the current protocol parameters that we just grabbed a little while ago. Okay. Cool. Good. Yeah. Okay. This tells us how many lovelace it's going to cost to send this transaction with 1 input, 2 outputs, 1 signature, and the current protocol parameters. If you use Daedalus and you've been watching closely, you might even recognize this number, 0.176413 ADA. This is probably the most common transaction amount, right? 1 UTXO in, 2 of them out. This is the fee for that. If you have been watching really closely, maybe you've noticed that sometimes the fee is not exactly this, even though it seems like you're sending a simple amount. Here's why. Watch this. So I'm just going to press the up arrow to take another look at this command. And I'm just going to change a couple of things. The witnesses is still the same. The outputs is still going to be the same. But in our second transaction, there's going to be 2. My command line's working weird. Never mind. I'm just going to type it all again. Got a little bug that I got to fix. But I'm not going to troubleshoot that live right now. I just want to get this video out. Okay, so TX2. Not much of this is going to change, but we are using the second transaction that we drafted, which was slightly different. The most important difference with this second transaction is it has 2 input UTXOs instead of 1. It's still going to have 2 outputs. It's still going to have just 1 witness. Obviously still on mainnet. Oh, darn it. And sorry, I forgot the slash. That's why it did that. And I forgot to I pressed enter without the slash. All right, so I should be able to go right here, though. File. And this one's going to be called TX2. Oh, out. Wait, what am I doing? Oh, sorry. Oh, my gosh. You see, this is embarrassing, but I'm just going to keep going. I didn't want to type out file there. I wanted to type... Here, let's use a slash so this is easier to see. Protocol params file. Just being a little sloppy here, but I hope it's humanizing and you're having a good time anyway. Okay, let's see if that works. There it is. Okay, sorry, my screen's a little messy, but what I really want you to notice is the slight difference between this fee for this transaction that has 1 input UTXO and the slightly higher fee for this one that has 2 input UTXOs. It's not significant, right? It's 3,300 Lovelace, or in other words, 0.0033 ADA, right? Less than, right, 1/3 of 1% of an ADA, which actually at current market price is about a penny, right? So it's a 1 penny difference. So significant, right? But the point is changing anything, the number of inputs, or you could see this for yourself sometime later, the number of outputs, the number of witnesses, the inclusion of metadata, the minting of native assets, all of these things change the fee for a transaction. They're all coming into play. It's deterministic, right? These fees are calculated by algorithms that we can all look at, right? And that will change over time. But this is the key, right? Is no matter what, depending on what precise parameters you're using and what kind of transaction you're submitting, the fee is going to change by a little, or in some cases by a lot. And we have these 2 different fees here. Let's save these numbers as variables. So the fee for the first one, 176,413 Lovelace. The fee for the second one, I see it right here, 179,757. Okay. And one reason it's hard to build a wallet is that calculating fees is hard. And one of the reasons it's hard is that you don't know what the UTXO distribution is going to be, right? If you have a wallet with a bunch of tiny UTXOs in it and you want to send 100 ADA or something, right? And that has to collect a whole bunch of different UTXOs. That's going to be a higher fee than if you just had a giant UTXO already. okay? I hope that makes sense. If it doesn't, let me know and we can try to explain it better, okay? But it's hard. It's not trivial to calculate fees because it really depends on the makeup of the wallet. And two wallets that each have the same amount of ADA in them may have a different UTXO distribution, and therefore the fee to send the same amount is going to end up being slightly different. Kind of interesting, right? All right, so we have these fees, and the only way to build an acceptable transaction is to make sure that you're conserving every single Lovelace that goes in. The Cardano protocol doesn't want Lovelace to disappear, or on the other hand, or to be created out of nothing, right? So what this means is that whatever you're putting in, you have to get it exactly right to a single Lovelace. If you do the arithmetic wrong, your transaction's not gonna work. So we gotta do a little bit of arithmetic here to figure out what the amounts are gonna be. And actually, this makes me realize I have to go back and look at these numbers again. So query UTXO at the address of the sender. Whoops, 3 N's. Let's get rid of that. All right. And let me fit it on the screen. Sorry about that. All right, let's look at this. So 5 million, that number's easy to think about. And actually the amount we're trying to send in each of these transactions is 4 million. 4. Good enough. Okay. And we have those fees now. Let's look at those one more time. Fee 1 and fee 2. Now we also need to calculate the change. In the first transaction, the change is 5 million, take away 4 million, which is 1 million. And then 1 million, take away this fee right here. So let me just, here, I'm gonna use my phone to calculate this. I know you can do arithmetic on the command line, but I feel like I'm under pressure right now and I can't remember exactly how to do it. I should have looked that up before. Here we go. Okay. So 1 million take away this fee is 823,587 Lovelace. Cool. For the second one, remember we said it was this 3,196,000, etc. Lovelace plus another 3 million for a total of 6,196,816. Yeah? All right. And then we're going to take away 4 million from that. And then we have to take away this fee right here, 179,757. And so the change for the second transaction is going to be 2,017,059. Okay. I didn't put a number on send because we're sending the same amount in both cases, but the change is different and the fee is different for each one. All right. All right. We've done the arithmetic. Thank goodness wallets do this for us typically. Now we need one more number here before we can go on. Oh, cardano-cli query the tip of mainnet. And what I'm looking for is this slot number right here. Cardano blockchain has been running for 39,380,000 slots. And right now, a slot is equal to 1 second. That's a protocol parameter. It doesn't have to be that, but it is. It's kind of elegant. But it might not be that forever. Who knows? Okay. For now, it is. And what we need to do is we just need to set an expiration time. So we're going to say that this or these, both of these transactions that we're about to build are going to expire. Let's just make it 81,810. I'm just adding 1,000 slots or 1,000 seconds, which is like 16 minutes or so. Okay. So I have to finish building, signing and then submitting these transactions within the next 16 minutes, which is good for you, dear viewer, because you don't want me talking for much longer than that, right? So what's good about this is what we know is that every signed transaction both has a signature on it and it has its inputs, right? Its UTXOs, and it also has an expiration. And if any of those things disappear between the time of signing a transaction and submitting it, the transaction will fail. Right? So if I could build a perfect transaction, but if I wait till tomorrow to submit it, it won't take it because I'm having it expire 15 minutes from now. That's good, right? I don't want potential transactions floating around that aren't being used and that might come back to extract value sometime later. Okay? All right. And sorry, and I lost my train of thought there for just a second. But the other thing is, right, if a UTXO disappears, right, if two transactions are built with the same UTXO as input, and one of them is submitted, now that UTXO is gone. And you can never submit another transaction that references that UTXO because it's been consumed. And this is at the root of what some really talented developers are working on right now, right? This is the concurrency issue. We need to be able to take different UTXOs from the same place so that different people can use a contract at the same time. I hope that wasn't too dramatic of an oversimplification, but this is the idea, right? I really want to help you start to wrap your head around this. Okay, so I probably just wasted some time there, and I hope that 15 minutes haven't passed yet, 1,000 slots. Let's keep going. All right, so I have this expiration. We're actually almost done now. Now we can build some transactions. I'm once again going to say build raw. Okay. And let's do the first one first. So TX in is TX in 1. There's only one of them. And TX out, let's think about this. This is, first of all, to the receiver, we are sending the send amount. I could just type 4 million right here, but I made a variable, so I'm going to use it, right? So address plus sign amount, right? I could just write the hash here of the address, and I could just write the number here. But I'm using these variables for now. Okay. And then the change has to go back to the sender. The sender gets the change, number 1. Cool. And this is where we can now come back to this thing. We ignored this before, invalid hereafter, but now we've talked about expiration. So this expires at this slot that we just stored as the expire variable. And we can say that there's a fee. We've calculated it for the first one. It's stored as fee 1. And we can store an out file called tx1 raw. And if it works, it doesn't look like anything happened, but now we've got that raw transaction file. Let's do it again. So cardano-cli transaction build raw. This time, we're going to have 2 inputs. TX into A and TX in to B. Okay. The outputs are going to be the same. TX dash out. Whoops. The receiver gets the, I shouldn't say they're going to be the same. They're going to be a tiny bit different. Watch. Okay. The receiver gets the send amount, which is the same amount. And the sender gets change 2, which was this amount right here, 2 ADA or so. Okay. We have the same expiration. Okay. Racing the clock. Got to get these transactions in. We have a slightly different fee, which we stored as fee 2. And we're going to make another out file called tx2.raw. Yeah? Yeah. Cool. Cool. All right. So we're actually almost done. We've done the hard part. We've queried the blockchain. We've gathered some information. We've gathered some UTXOs. What else did we do? We built some transactions. We did some arithmetic before that. Now we just need to sign these raw transactions that we built and finally submit them. This signing part is cool because it can happen off-chain. So if you've ever heard of an air-gapped machine, this is the part that can happen on an air-gapped machine. And if you're dealing with significant amounts of value, absolutely do it this way, right? Grab the raw transaction, move it over to an offline computer, sign it with the private keys that are stored on your offline computer, bring it back to your online computer, right? Change that invalid hereafter if you need 30 minutes or an hour, right? Change that expiration accordingly to give yourself time to do this. Bring it back and put it on, right? So the step we're doing right now can and ought to happen offline, okay? But like I said earlier, because I'm talking about 30 ADA worth of value, I'm choosing to show you this, okay? And that's worth the risk to me, is to expose you to how this works, okay? So what are we signing? We're signing the first raw transaction. What are we signing it with? We're signing it with the signing key file, which I stored the path as this variable sender key, right? Just a little bit of appropriate security. I'm not showing you that. Where are we submitting it to? Mainnet. And we're just going to make one more output file called tx1 signed. All right, that should work. It did. Okay, let's do it again. Sign. This time we're signing. Woo. I'm racing the clock. Get this in. Same signing key file because the UTXOs are coming from the same place. That's all good. Still mainnet. And this time, all right, we now have 2 signed transactions, and we're finally ready to change the Cardano blockchain. We haven't done, nothing we've done yet has changed the blockchain, right? We've gathered a little bit of information from it. We grabbed the parameters. We looked at the existing UTXOs that are associated with these addresses, but we haven't pushed any new information onto it. Now we're about to do that. The last thing we're going to do, and I love this because this is the easiest part, right? All we have to do is now submit it. Watch this. Cardano CLI, transaction submit. What are we submitting? We're submitting this tx1 signed file. And where are we submitting it to? Mainnet. Watch this. Uh-oh. What happened? It wasn't like it was supposed to. What happened? Transaction submit error. Transaction validation error. It doesn't like it. Why? There's an apply transaction error, UTXO failure, output too small. Yikes. Why? Do you know? How much change were we sending back to the sender? You see, remember how it was less than 1 million Lovelace? Maybe you've heard of the minimum UTXO requirement. A valid UTXO has to have at least 1 million Lovelace in it, a minimum of 1 ADA in a UTXO. this constraint may not exist forever. That's a decision of everybody with a stake in the protocol to argue about and make some decisions about over time. But for now, that constraint exists. And because I tried to send less than 1 ADA in change, this transaction was rejected. Okay, that's good. It should have been, right? And I just wanted you to see that, all right? Now, let's do the other one, though. TX2. Is this one going to work? Yeah. See that? Okay, so I do get a little bit of feedback that the transaction was successfully submitted. So hopefully in your head you're thinking about this now, right? We've got some UTXOs. We bring them together. We build a transaction. If the transaction is valid, it passes, like we did here. And if not, it doesn't, and we're given a reason why. In Plutus, there's just more ways. Let me see here. Transaction build raw. In Plutus, we just get more ways to build transactions. Check it out. Right? So we've been just working on mainnet for today, but the Alonzo error is coming, and you can see that reflected here in the usage of Cardano transaction build raw. Scripts, I didn't show you anything about that yet. Collateral, you're going to start hearing a lot more about that if you're paying attention to dev conversations. Minting, I'll cover that in an upcoming starter kit. Metadata, I've covered that before, and I'm going to do it again real quick soon. And then you see some other words that if you've watched any Plutus Pioneers, maybe you've heard these, but if not, check it out. Datum, redeemer, collateral, minting redeemers and scripts, etc., etc. Transactions are getting more interesting, more powerful, and obviously more complicated. But under the hood is everything I showed you today. You're going to build transactions, and if you do a good job at it, and you follow the rules of the protocol, which I didn't with that first one, your transactions are going to pass. If not, they won't. And what Plutus does is it gives us more rules for building acceptable or valid transactions. There's still other problems. Concurrency and parallelism. What happens when two entities are trying to grab the same UTXO at once? Well, it can only be used once. Once it's consumed, right? And there's been this kind of misconception being spread that each block can only have one transaction. That's not true. A block on the Cardano chain can hold an arbitrary number of transactions. But what is true is that each UTXO can only be consumed once. Okay. Well, now we start to see another difference. If I have 100 ADA in a wallet, there's a big difference between that 100 ADA being in one UTXO versus being spread out, over 10 by 10. Because if I have one UTXO with 100 ADA in it, if I want to send money twice, I first have to send the first transaction, get the change, get the new hash, and then send another transaction. Whereas if I have a set of smaller transactions, UTXOs in a wallet, now I can work in parallel because I've got these different UTXOs that really have nothing to do with each other, right? The only reason that first transaction failed that I was just showing you a few minutes ago was because it didn't fit the minimum UTXO requirement. But if it had, right, if I had been trying to send 3 ADA and the change was 1.8 instead of 0.8, that would have been fine. And look, let's go query both of these again. Cardano CLI query UTXO mainnet at the address of the sender and the receiver. Right, this one now has a new UTXO with 4 Lovelace in it. This wasn't touched because the transaction failed, right? This UTXO right here still exists, just like it did before. I tried to consume it, but I failed to consume it, so it still exists. But some of these other ones, right, they don't anymore. Here, where's the change? Was this it? Echo change 2. Oh, 2.01. So that's this. Here's a new UTXO. So, right, the 2 UTXOs are gone that I combined to make 6 point something ADA. And here's the change right here now back in the wallet. And if I go back here and I refresh this page, now it shows 9 ADA. You could see that transaction we just built. Total output was a little bit over 6, right? That was the sum of the 2 inputs. There's those fees that we calculated. Okay. And if I go to this other wallet and I refresh, the other address and I refresh, I should be more precise. We have about 4 ADA less, and then the fees as well. And you can see that transaction here as well. All right, I think we'll stop here for today. I'm never sure if I said things clearly enough when I make these starter kits. So if there's anything that I skipped over or that you wish I had explained differently or better, please leave that feedback in the comments and let's keep building better documentation together. If you're a dev who already knew this stuff, thanks for checking it out. I hope I didn't bore you too much. And I hope I said things right. And if you're brand new to this, wrapping your mind around the UTXO model, this video was for you, and I really hope it was helpful. Be in touch either way. All right, hey, thanks for spending some time today. Let's go out there and build some amazing things. I'll talk to you soon. Bye.